There are all kinds of control panels in various locations. Engineers have engaged in the daunting task to prevent such explosions and fires. One of the principles was developed is the hazard triangle. There are hazardous area general principles which form the creation of the hazard triangle. In this triangle, there are three ingredients. If these three are present and the ignition source is introduced, then an explosion or fire will result, but only if the gas-air mixture is within the upper and lower flammable limits. Important characteristics regarding ignition are flammable limits, flash point, auto-ignition, minimum ignition electrical energy, and ignition source. Here are some flammable limits of common gases with the percent of mixture, gas and air, in an enclosure or vessel. Definition of flash point: lowest temperature at which a flammable material releases sufficient molecules from its surface to form an explosive mixture with air. The definition of minimum ignition of energy is the lowest possible electrical energy occurring during discharge of a capacitor, which can ignite a mixture of gases or vapors and air at atmospheric pressure at a temperature of 20 degrees C. In a hazardous area, we need to know the classification. In North America, the National Electric Code, Article 500, has them broken down into three classes. Class 1, flammable gases, vapors, Article 501. Class 2, combustible dusts, Article 502. Class 3, ignitable fibers and flyings, Article 503. Article 500.6 further breaks down the classes into groups. For Class 1, Group A, acetylene. Group B, hydrogen. C, ethylene. D, propane. In a Class 2 location, Group E, we have metal dust, conductive and explosive. F, carbon dust, coal, charcoal, coal dust. G, flour, grain, starch, etc. In a Class 3, we have textiles, woodworking, etc. The last step in classification is the division. Division 1, hazardous in normal operation. Division 2, hazardous in abnormal conditions. Here we have a chart that describes Article 500. We have class, group, and division, although we label components as class, division, and then group. To sum it up, we ask, is there vapors, dust, or fibers? Is it abnormally there or normally there? And what gas, dust, or fibers it is? In North America, there is now a shift towards the IEC zone classification and ATEX directives. The key elements of IECEX and ATEX, they are technically identical standards. When using IEC standards, a single set of tests and assessments can be used for both, and the QA audits are the same. To start the explanation of the European model, the discussion starts with the zone. Here is the zone based on the IEC European model. A chart of classification is presented here. Essentially, Zone 0 and 1 fall in line of Division 1, and Zone 2 into Division 2. The zone system has 3 levels of hazards versus the 2 in the division system. There are no equivalents for fibers or flyings. Combustible dust falls under Zones 20, 21, and 22. There are zone gas groups as well, followed by a more complete listing of atmospheric groups. This chart is divided into substance, ATEX, IECEX, and North America. Incidentally, ATEX is atmosphere's explosibles. The following is a definition of the temperature classification. The T rating has a temperature equal. The chart will show the T rating and the temperature it represents. We have the NEC IEC ATEX rating. Obviously, the 85 degrees C or T6 rating is the best because the flash point of any gas would be above that. This chart is new to 2017 for ATEX marking. ATEX covers equipment that satisfies three criteria. 1. It must be purposely designed for use within an explosive atmosphere at normal temperatures and pressures. 2. The atmosphere may contain gas, vapor, mist, or dust as a fuel, but must be based on air as an oxidizer. 3. The equipment must have an ignition source in and of itself, such as a spark, hot surface, etc. The first three items are the CE mark, body responsible for the approval, and the European Commission mark and ATEX marking. The next digits outlined here is the equipment group, Latin capital II, meaning surface industry, and I, meaning mines or underground industry. The next outlined digit is the equipment category, 1 for Zone 0 or 20, 2 for Zone 1 or 21, 3 for Zone 2 or 22, M1 for mines, which is equipment to remain active in an explosion atmosphere, M2 for mines, equipment to remain de-energized in an explosive atmosphere. The next outlined digit is for surrounding atmosphere, G for gas, and D for dust. The EX outlined here is just to state explosion protected. Then it's followed by the type of protection. The type of protection has a lot of options. Let's finish the rest of the marking description and come back to this. The highlighted digit has Latin letters II for gas grouping, with an A for propane, B for ethylene, C for acetylene, and hydrogen. Letters II with an A for combustible flyings, B for non-conductive dust, and C for conductive dust. This highlighted digit represents the temperature class under a gas group. Temperature classes were talked about earlier. Under a dust group, maximum surface temperature is 125 degrees C. Under a mines group, maximum surface temperature is 150 degrees C. The last letters is for equipment protection level, and there are many options. This slide has the equipment level highlighted. M is for mines, G is for gas, and D is for dust. The zones are defined when the ATEX directory category is either 1, 2, or 3. Please recall that the equipment category was the fifth grouping in. Let's go back to the types of protection. DE shown highlighted here. In this series of slides, we have the type of protection such as flame-proof EXD and AEXD, explosion-proof Class 1 Division 1. These contain the explosion and prevent flame propagation. Also, we have increased safety EXE and AEXE with non-sparking EXNA and AEXNA. And then there's non-incentive, NI, Class 1 Division 2. Those items have no sparks or hot surfaces. Next we have pressurized, EXPX or AEXPX, Type X, and Type Y. Those are good for Class 1 Zone 1s. Type Z is only good for Class 1 Division 2. Each of these keep the flames out. The next type of protection is for combustible dusts. Protection by enclosure is EXTB or AEXTB, EXTC or AEXTC. Goods for zones 21, 22, Class 2 Division 1. Then there's dust ignition proof or DIP, Class 2 Division 1. Then there's pressurized protection by pressurization, EXPD, AEXPD. There's PX, PY, good for Class 2 Division 1, and PZ, which is Class 2 Division 2. Then there's EXPD for Zone 22. All of these are to keep combustible dust out. This particular chart has newer codes and symbols. We have encapsulation, symbols MA for zones 0, 1, and 2, MB for zones 1 and 2, MC for zones 2. Then there's sealed hermetically, NC for zones 2. Then there's restricted breathing, NR for zones 2. Oil-filled, symbol 0 for zones 1 and 2. Those are designed to keep the flame out. Next is sand-filled, symbol Q, quench flame for zones 1 and 2. Then we have optical radiation, listed as OPSH for zones 0, 1, and 2, and OPIS for 0, 1, and 2, and OPPR for zones 1 and 2. These are considered inherently safe. This newer chart for combustible dust has the enclosed method for TA, zones 20, 21, 22, TB for zones 21 and 22, TC for zones 21 and 22. Then there's intrinsically safe, which is IAD for zones 20, 21, 22, IBD for zones 21, 22, and IAC for 21, 22. Lastly, we have encapsulated for symbols MA and MB for zones 20, 21, 22, and symbol MC for zones 21, 22. This chart is for IECEX marking, and you should notice it is the same as the last 5 markings in the ATEX model. Here is the NEC division system marking. We already talked about these. The class being Class 1, gas and vapor, 2, dust, 3, flyings. And Division 1, normally explosive and hazardous. Division 2, normally not present in an explosive concentration as an accidental rupture. A, B, C, and D are gases. E and F are dusts. G is flour and grains. The temperature codes we discussed earlier. The zone system marking is a combination of the US and IEC/ATEX markings. The categories shown here are the same as we have discussed earlier. Here we have an enclosure example. We have a Krauss-Heinz EJB enclosure. The ratings in the US, Class 1, Div 1, and 2, groups B, C, and D, which means Class 1, gas, always or and normally present for gases, hydrogen, ethylene, and propane. Class 2, Division 1 and 2, groups E, F, and G, which is metal, carbon dusts, and flour. And Class 3 for everything with fibers and flyings. The IEC side, we have EXD for Zone 1 plus Class 1 Zone 1. A gas rating, B ethylene with hydrogen. And a T6 temperature rating, which is expected because there's nothing inside the box. It's when you add things that change it. We also have some NEMA and IP ratings, which we'll explain later. Which enclosure should I choose? Article 505 has 9 permitted protection techniques. The table helps you quickly see which protection techniques apply to its zones. An important fact that it's hard to spot in the NEC text is easy to spot in the table. All of the protection methods apply to Zone 1 and Zone 2, but only 2 of them apply to Zone 0. You can use intrinsically safe systems and oil immersion regardless of zone, but you can't use other techniques in Zone 0. Here's an example of a purged or pressurized enclosure can be used in a Class 1 Division 2 location. The next couple of slides will talk about NEMA and IP ratings. NEMA stands for National Electrical Manufacturers Association, and IP is an IEC derivative of Ingress Protection. In this chart we have NEMA 1 as general purpose, NEMA 12 dust tight, NEMA 3R is rainproof, NEMA 4 is watertight, and NEMA 4X is watertight, corrosion resistant. This chart lists what I just mentioned and a few others like NEMA 6 and 6P. The IP chart is a bit more complicated since you have to combine two of the number codes together to get a rating. The Krauss-Heinz enclosure had an IP rating of 66, which makes it a complete protection of high jets of water in all directions. There is no real exact reference between NEMA and IP, but this chart will give you a close proximity. As you can see, IP66 is NEMA 4X. Any penetrations must meet or exceed the same NEMA rating. For example, a NEMA 12 push button used in a NEMA 4 enclosure, the enclosure rating is reduced to NEMA 12. Wire management. In a Class 1 Div 1 area, threaded rigid metal conduit or thread steel intermediate conduit, type MI cable terminated with fittings listed for the location, type MC/HL listed Class 1 Division 1. Conduit seals are required within 18 inches of the enclosure. Flexible connections permitted when necessary if rated for the location. In a Class 1 Division 2 location, all wiring methods from Class 1 Division 1 are accepted. Wireway accepted if it closed and gasketed. Type PL, TC, ITC, MC, MV, TC cables with listed fittings. Flexible connections permitted when necessary if rated for the location. Conduit seals must be used within 18 inches of the explosion-proof or purged panels. For this particular skid, we have a Class 1 Division 1 location. The contactor is an explosion-proof enclosure. The main panel is a NEMA 4 purged. Inside are IS barriers to various field devices. We have conduit seals and cable glands as necessary. The purge unit monitors the pressure within the enclosure and controls the contactor.